dealing with large data. So I think you got the taste of machine learning. It has various use cases. It's used in spam filtering, your spam box in your Gmail filters spam, whether it's spam or not spam. It's a machine learning model. Or it can use it in risk classification. And when you use social media apps, they can only show you ads based on this only. So these are various uses of machine learning and artificial intelligence. So now moving on to supervised learning. So what is supervised learning? Basically, supervised learning is a type of machine learning algorithm in which what we do is we feed the model. Suppose this is our model, training model. We feed some label data to it, and based on it, we produce a output for us. Now, what is label data? So here you can see that we have a shapes like hexagon, triangle, square. So we will feed our model with the labels of it. Like if the shape is like this, then it is an hexagon. If this is triangle, if the shape is like this, then it is a triangle. We will give the labels also to the machine learning model. After we give it the label, we test it on the data, like we will only give the shapes and it will predict the label for us. This is what supervised learning means. Like we are feeding the model with label data for which the value we already know. And after that, it will produce on the test data. So I think you can guess what unsupervised learning means. So I will get to it in the session. For now, you can see supervised learning could be divided into two parts. One is regression, like it could be we could use it to solve two different type of problems. One is regression and another one is classification. So what is regression? Regression is basically when we try to predict some continuous output. Like whether the temperature outside is 84 degree Fahrenheit or 85 or 84.5, anything, which is like numerical any continuous value. So this type of model is called regression model. And classification is like we classify different things, whether it's hot or cold, true or false, right or wrong, anything. We classify it into two, whether it's in spam or not spam. These are classification problems. So we take models, we take supervised learning model to do these two things. Okay. So now let's move on to one of the regression model, a very simple regression model, linear regression. So linear regression is a supervised machine learning algorithm or model which tries to fit. So here you can see that in the x-axis we have some variables, some input which we give, and in the y-axis is the output. So what we call is we have some independent and dependent variable. What are dependent variables? Dependent variables are the variable which we have to output, which depends on the independent variable which we put into the system. Independent variables can be 1 to any number which we give to the model, and it will predict some output which is a dependent variable. What we do in machine learning is we try to fit a best fit line between these two variables, such that it tries to fit a line such that we get the output of the data which we are not aware of. Like when we test the data, suppose here you can see these all cross marks are the observed data which we have got. These all are training data. So what we do is we try to fit a best line out of this. Here you can see how this without this line you can visualize how these cross variables are highly correlated. They are something which are aligning a line. So we try to fit a best fit line out of that, so that when we get a new data for which we are not aware of the output, we get the output. Suppose we are not aware of what is the output for 95 here. So based on that we can see we can observe the line for the value such that for a particular value y for a particular value x what the output we are getting. So the equation of the line. So this is our linear regression is. Now moving on, let's try to understand the mathematics and the intuition behind it. So till now we understood what is linear regression, like what we do. We try to fit a best line out of it. Then the question is how do we exactly do it? So the core concept is the mathematics behind it. So here you can see on the hypothesis that we are predicting this x is our output variable, which you can see the equation of a line. What is the equation of a line? It's an intercept when we know the slope and the intercept of the line, we can write the equation of the line. It's mx plus c. So here theta 1 is the slope and theta naught is the intercept. So this is the equation of the line which we just showed, and we call it parameters here in machine learning. Theta naught and theta 1. So these are the parameters. So now the goal is to fit the best line. So how we will do it? We will find the error in it. We will see the error between the observed data, like this is our observed data, and this is our line which is predicting the output. So we will calculate the difference between it. This is the error we are getting. So our goal is to minimize that error as much as we can. So for that, we use the cost function here. Cost function is like a function which we try to minimize. We try to minimize the cost associated with it. If the cost is, if we want the cost to be as minimum as possible, so that our model is as accurate as possible. So for that, here you can see that this x is our output, like the output which our model is predicting, and y is the real output which we are giving to it. Like we know for training data we know the real output of what it is, and it is the output which our model is predicting. So we want this error to be minimum. So what we do is we take the difference of it, and just to take a positive value, like the error could be negative also, and we don't want that. So we can square it and take the mean of it. M comes due that we take the mean of it, and this becomes the cost function. Now we are thinking what this 2 is. So we sometimes take that 2 only to simplify the calculation, which we will do further. Like some people don't take it, but some people take it. So we do it to just minimize the error, minimize the simplification, simplify the mathematics which we do after it. So the goal of this cost function is we have to minimize this cost function as much as we can. For that, what we could do? How we minimize the function? We do it by differentiating it and equating to 0. If we differentiate it and equate to 0, then suppose we are here and we differentiate it and equate to 0, then we can write here. This is the minimum point. And we want to find the price parameter that is like theta naught and theta 1, so that we get the least cost as much as we can. So this is the goal, and so to do is we differentiate it and equate to 0, and we get those values. There is a concept of gradient descent also to do it, and I will come to it later. Secondly, let's come to logistic regression. Logistic regression is basically a classification algorithm. It tries to classify two. It tries to find there are different types of logistic regression. Here we are saying binary classification. So it tries to classify the input into two parts, like whether it's a 0 or 1. This is a binary classification. So what we do here is we use a function. We use a function called sigmoid function. This is a sigmoid function. Gx is equal to 1 upon 1 plus e raised to power minus z. What this function do? This function, like you just saw the graph here. This is the graph of this function where we are giving z as the input, and we are predicting we are getting a value between 0 and 1. And our goal is to get the value as close as 1 or as close as 0. We don't want the value in between. So that our model is like logistic regression basically predicts the probability of getting 1 or 0. If we are getting something very close to 1, like 0.9, then we are very much sure that the answer would be 1. If we are getting something very close to 0, then we are sure that we are the output will be 0. So we try to get as close to 1 or 0, so that our cost is minimum. Now, so this is the sigmoid function, and what we do is if this is our function, and this is our output also. We here you can say as equal to g theta dx. What g theta dx is? It is the z here. Where theta is the parameter and x is the input variable which we give. So you can see that when we give something to our function, it will predict some values between 0 and 1. What we will do it if our predicted value is greater than 0.5, like in the graph you can see, if we are getting something greater than 0.5 as the output, we will predict it as 1. If we are getting something less than 0.5, then we will predict it as 0. So this is our goal. Our goal is to get as close to 1 and 0, but if we get some value, any value greater than 0.5, then we will predict as 1, and less than 0.5, we will predict as 0. Now, what is the cost function here? Like how like you can yourself think what we want to do here. We want to get as close to 1 or 0. We will make our cost function. if our output is 1, then we are using a different cost function that is minus log, and if our output is 0, then we are using minus log 1 as assets. So you can think why we are using it. Like suppose the output is 1, and if our model is also getting 1, then you can think what is log 1. Can you guess what is log 1? 0. So we are getting 0 cost. That is what we want. We want the cost to be less and less. Suppose our two values 1 and we are predicting 0, then our cost function will become minus log 0. That's an infinite value. So we don't want that. So this is how we penalize the model if it is performing first in it is performing first in a test case. And like you can see for y equal to 0, if the model is predicting 0, then it will become log 1. That is what? 0. So if like that, we can see if our output is 1, so we want our model to predict 1, 0. 1. If our output is 0, then we want our model to predict 0. Just like that, we can function our cost function. So this is the cost function which comes up after we add this. Like if the output is 1, then we will use this. If the output is if the y value is 1, then this will become 0. So we are not using it. If the output is 0, then this one becomes 1 and this one becomes 0. So we can like add those numbers mathematically so that we can use it at once. And here also we will the mean of it by dividing by n. And here also we have to minimize the cost function so that we get the best accuracy. Now, here comes the concept of gradient descent. So this is our cost function, and here you can see that we have weights. Like weights here is the parameters which we are giving, the input we are giving. And in the y-axis we have cost function. So suppose we have a parameters which is giving this cost as the answer. But what we want is the cost to be minimum, not 0. The cost will never become 0. If it is becoming 0 in the training data, that means we are overfitting it. Leave it for now. So like here you can see we suppose firstly we are spending at this cost function. Our parameters are such that we are getting this cost, but we have to come to this point. So gradient descent does this beautifully. Here what we do is suppose our weight is greater than what we want. So we will subtract some quantity from it. For that we use this function theta is our parameter. We subtract a positive value from our theta so that we get to the point which we want. So how this is positive value? This alpha is called turning rate. This value is between 0 and 1 generally, and we like the running rate shows how fast we want to move to our point. If the running rate is high, we will be moving very fast to a point. If the rate is less, then we will be moving very slow. So how this is a positive quantity? You can see the slope here is positive. If our point is here, then the slope is negative. So here, if the slope is positive, then we are subtracting some positive quantity out of it, so that we could get to this point. Suppose our point lies here, firstly, and we want to get here. So we would with the formula we see, here the slope will become negative. You can see the slope here is negative. So this quantity will become negative, all of this quantity will become positive, and we will add something to the parameter, so that we could get to the best parameters which we can, so that the cost is minimum. So this is what the concept of gradient descent is. It could be used in linear regression also, and the concept would be same here. We would be subtracting some quantity so that we could get to the right cost. Now, here comes K nearest neighbor algorithm, which is KNN. It can be used both for regression and classification. So here you can see that we have this graph shows for classification. We have a category like category A and category. These two type of classification we have initially, and we got a new data point there. This blue one. This blue one is a new data point which we got, and now our goal is to classify this data point as category 1 or category 2. So how we will do it? Here KNN, K nearest neighbor. K stands for the number of data points which you want to see. It could be any number. It could be 3, 5, 7. Generally, we take odd numbers just to avoid time later. So suppose we take any number like 5. So we could see what are the 5 closest data points to this new data. What are the 5 closest new data points to this new data? And you will see that suppose we are getting 2 data points from category B and 3 data points from category A. These are the 5 nearest data points out of these. So what we will predict is we will predict our output as category 1, because there is greater than 2. Category 1 is more dominant here. So like that, we check for how many we check for how much data point our new data point is closer to. Based on that, we predict some output. Suppose we insert the value 4 and we got the data like two data points are closer to A and 2 are closer to B. Then how do we predict? So that's why we take odd number here so that we can predict a particular value. This is how classification works. And for regression, what we can do is if we get a new data point, we can take the mean of the closest 5 values. So that like what we assume is the new data point has the same property as the other closest similar points out of there. So this is the assumption here. Based on that, we can predict any output. So if we take a smaller data point, then it can be noisy, like the cluster will be very, it could be very, it could very overfit, and we would be in trouble. And if we take very large key value, then if any category is very dominant, then new data points will classify it into that. These are, if you go into detail of it. Now comes the unsupervised part. So till now, like if I try to simplify as much as I can the models, like I have taught you the simplest model which is available in machine learning. You can see that supervised learning is almost 2 times, and I think you have got some few of it. Now comes the unsupervised learning part. In unsupervised learning, what we do is we feed the model with unlabeled data. Now, what do you mean by unlabeled? Like I just told you what is labeled, which is something like which we give to the system, labeling it, whether it's what is quantity exactly it is. But here we don't give the labeled data. Our model by itself discover patterns and try to find the relationship between it. By itself, it does that. And this is what unsupervised learning is. It is basically classified in many parts. 3 parts I have written here, which are reason. Those are clustering, dimensional, reduction, and weight detection. So when we look at clustering, it also has many types: hierarchical clustering, density clustering. We won't discuss all these clustering here. We will discuss only one type of clustering, that is centroid clustering here. And for dimensionality reduction, we have PCA, principal component analysis. What it does is in machine learning, we have to deal with data, right? And daily, like billions and billions of serial data is generated. And how do we use it? Like we need big servers for it. So PCA sometimes does the work for us. It reduces the dimensionality of the data so that our data get reduced to a lesser GB storage, lesser storage. How it does is that it tries to find a new line so that we without losing vital information, we could reduce the dimension from something bigger to something lesser without much loss of the data. Like some data would be lost, but we would try as much as we can that we lose as less data so that we could get so that our model doesn't become underperformed. Now we will see one of the clustering algorithm, that is K-means algorithm. It is a centroid-based clustering. It is a unsupervised learning model. So here what we do is, suppose we have to make clusters. Okay, clusters, you understand? Like here we have our data points and we want to make 2 clusters out of it. So you can guess we would make our first cluster in this part and second cluster in the other part. So earlier initially we don't know what our cluster will be. So what we do is we decide our k value. K is any number which we want to make. How many clusters we want to make? Suppose here we want to make 2 clusters. So we took 2 centroid points. Centroid point is any random point which we will take initially. After that, like here we have taken 2 process as our initial centroid point. Initial centroid. First, you can guess this is not the centroid. Here centroid. It's just a random centroid which we do. Now our goal is to get to as close as the our goal is to get as close as to the center of the cluster so that our array is minimum. Let me show you. This is the cost function. Here also you can see xi. It is the data points which we are seeing, and mu c is the centroid of it. So we want the error to be minimum, like the difference between the data point and the centroid of it should be minimum. In the initial case, we saw that some data points are too far, like if we say each data point which is this is too far from the initial cluster, we don't want that. We will penalize it. We will penalize it in such a way that the difference between these data points are as minimum as we can. So for that, initially we will initialize a data point of a cluster centroid. Then we will find the difference for each data point, like for each data point, we will see which cluster centroid is at the minimum distance of it. If suppose we look at this cluster point, we will see that this centroid point is more closer than this. So we will classify it in this cluster. After that, for each data point, we will see. So we can see that this all red dots got classified in this cluster, and this all blue dot classified into this cluster. After that, we will again find a new centroid point such that we might on the new cluster we will find a new central point such that wherever the cross function is minimum. We will take of the new data points, we will again take the centroid of it, and suppose we got the centroid here, and of the second cluster we got the central point here. So we will leave this central point as it is, and we will now our new central point becomes this. Again, we will check for each and every data point what are the closest value of it, and what are how. And likewise, we will take clusters, and again we will take the centroid or out of it, and we will do it repeatedly till the point we get two clusters with for which our cost is minimum. So this is the concept of K-means clustering. So I think you have got what is machine learning basically. Machine learning has various aspects. If we try to build models out of the data points which is available, so that the model can state and it predicts something, it takes decision by itself. Now, another part of it is deep learning, which I just told you is it's a neurons, we use neurons to make this model. And this is also a very promising field, very developing field. This is getting bigger and bigger. This aspect of it is getting bigger and bigger, and it is used for various cases. In astronomy, the use of deep learning is more vital. So, my friend once put out reading from here, and he could explain you what deep learning is and what I see at all. So, I will give the mic to Vance.
हेलो आवाज आ रही है सो बहुत मैथ्स हो गया अब थोड़ा न्यूरॉन्स थोड़ा बायोलॉजी की तरफ से सो डीप लर्निंग सो व्हाई डू यू थिंक इट इज कॉल्ड डीप लर्निंग एनी आइडिया एनीवन कुछ भी नाम रख सकते थे व्हाई डीप किसी ने नहीं सोचा ना सो द रीजन इट इज कॉल्ड डीप लर्निंग इज when we build neural networks, like you can see, this is just an illustration. जैसे हम लोग we keep on adding layers, we keep on adding hidden units. These circles, what you see here, these are called hidden units. So as we keep on adding them, there are around 20, 50, 100, 200, 500 layers. So imagine the depth of the network, which has 500 layers. And each layer has around, let's say 100 or sometimes 2 to the power 10, that is 1024 hidden units. Imagine the depth, imagine the precision that it can get. So that is the reason why we call this as deep learning. And so as you can see here in this Venn diagram, AI, artificial intelligence, it's a whole broad spectrum. And there's a part which is called machine learning. And just for your knowledge, the part which is left, ये blue वाला सारा, this is basically AI ethics and everything that is related to not the math but the psychology and the biology part. We do not discuss that here. We are engineering students, so we know math, right? So machine learning, and then comes deep learning. यहाँ पे प्रतीक नहीं रहा होगा, but this is deep learning. So deep learning is a part of machine learning which uses neural networks to predict outcomes, to predict future, as I should say. And this is the field where extensive use of neurons happen. We don't use clustering, we don't use statistics. We do use statistics, but not in a very broader sense. Okay, so let's move on to the next slide. Okay, I want you guys to differentiate between these two images. Give me one difference. सीधी बात ये Chinese लग रहा है American लग रहा है. And now I want you guys to find a similarity. नहीं, not humanly similarity, but something abstract. Complexion could be, but that's not what I'm looking for. Maybe, but मैं वो नहीं सुनना चाहता. हाँ? नहीं, same तो क्या तो Chinese है वो मैं. तो ठीक है. So the similarity between these people is, I might क्या कहना चाहिए? Chalk सकते हो तुम लोग. You might, everyone of you might get started, but these people in these photos are in fact not real. किसी को लगा नहीं? वो दोनों photos, ये और ये बंदी. These people do not exist. So this is the beauty of deep learning, because using the faces of people that do exist, we can build faces of people that have not walked the planet Earth. So just try to get the essence how beautiful it is. That these people in these photos, in fact, are not real. Yes, these people do not exist. And to give you a demo, just a second. I might take some time, but okay, sorry, the site can't be reached now. I'll tell you afterwards. This is the reference, by the way. This person does not exist.com. So this site exclusively gives you photos of people who have not existed until now and might not exist, because it gives you thousands of photos. So this is pretty good chance. So an architecture called StyleGAN is used to generate these almost real faces. StyleGAN is a modified architecture of generative adversarial networks. Anyone here knows about generative adversarial networks? Okay, I'll tell you about it. It's in the last slide, which is capable of generating real-life images. So if you guys are not established, but I'm judging effectively. So next, yes, artificial neural networks. So this is what is artificial neural networks, or what we call this is this given here. This is called a perceptron. It takes input. Here it does mathematical stuff and it gives output. A typical KNN, and a single unit, it's called a perceptron module. Okay, so it is inspired by this. This is the biological neuron. So I don't know much about it, but I think it takes input from here and gives from here, right? ऐसी कुछ होता है ना? Synapses से input आता है बाकी neurons का, dendrites के through बाकी को जाता है, right? So yeah, that's how it is. It does not do any mathematical stuff. Just remember that. This does mathematical stuff. But mathematics is what I tell you. So the term artificial neural network is derived from biological neural networks that develop the structure of human brain, similar to the human brain that has neurons integrated. That. Then right, yeah. So there's an analogy between biological neuron and artificial neuron. Dendrites are the inputs, cell nucleus, also called RNA, that is node, axon, output, synapse, internet. Cool. Next. This is the one. So, this f of x is the mathematical stuff that is done inside the perceptron. G with Fk, with F2, F1, all the way of x. Okay. So this G, this is usually, sorry, this is basically what classifies the neural network as a regression model, binary classification, or multi-class classification. So you guys might not be able to see this, but here this is softmax function. Softmax is basically e raised to the power of x, xi is the let's say the input that we are really concerned about, and in the denominator we have the sum of all such exponential terms. So you get the idea that it's kind of like getting the ratio of that particular neuron, that particular input, with by the sum of every possible input, right? So this is what is in a multi-class classification. Binary classification is like classifying. We have only two classes, so we can do that. Yeah. Regression, as my friend just told, we have this equation and we try to find WK plus 1 and PK, if you guys PK plus 1, if you guys can see. And here, the A part in Fi of x, A is the non-linearity. This basically, you know, right, that the equation that you see here, Wix plus Vi, this is a linear equation, right? So, what if the data is structured somehow that we have to find a curve? We want to have a curve that classifies it correctly, right? So, for that, we would need a nonlinearity, which is sometimes this. This is the softmax function, which I was talking about. Logistic, this is used in logistic regression as well. And CANH, this is used in LSTM, long short-term memory networks. And ReLU, this is used in everyone. Like this is the standard function. Yeah. So this is equal to maximum of 0, x. So like if you have input and you have 0, if the input is negative, it will return 0, and if it's positive, it will return x. Very simple. Okay, this is the what you call the neural network. Input layer, hidden layer, and this is the output layer. Cool. Next, convolutional neural networks. So, how many of you have an idea about CNN, computer vision? Raise your hand. You see what you need? So, convolutional neural networks, also called CNNs, these are explicitly, not explicitly, but 99% of time are used for image classification, image processing, image generation, you can say. Yes. Not image generation for image generation के अलग networks होते हैं, but उनमें भी basically CNNs ही use होते हैं. So CNN are, if you have an image, you have to have a CNN. That is what I say. So a convolutional neural network, also known as CNN or ConNet, is a class of neural networks that specializes in processing data that has grid-like topology. So grid-like topology. What do you understand by grid-like topology? Do you have any idea? Grid and grid-like topology. Okay, topology is basically the surface. Okay, what you can see. So grids are basically, imagine you have four, what do you see? So four vertical lines and four horizontal lines, right? And you put a square on the boundary. We have a grid. Okay. So whenever the input structure, input data has grid-like structure, we use CNNs. And why that I will tell you. So I think it's written here. Visual image is a binary representation of visual data. It contains a series of pixels and in grid-like fashion. Again, grid-like. Here. So this kernel is this yellow box. Okay, you guys can see, right? This is the yellow box. So what this does is, I think I should go on to the next. Yes. So this is the kernel. Okay, so this kernel, basically kernel size you can vary as you like the code. Usually it's taken 3 by 3, so 9 kernels are present in that. And what we do is the typical what should I say? The typical size of an image is 224 to 224 to 224, let's say. Okay. So what it does is this 9 by 9 kernel is put over that grid-like structure. Okay, and the first nine, what should I say? Let's say blocks. First nine blocks, it has some mathematical, it has some functions, it has ones or zeros as it's shown here. So uh, it's put over there, and corresponding to every block of the kernel, it performs the mathematical operation on that block of the image of the input, right? And then it can either average it, it can either put a ReLU function on it, like I just said, or it can do anything. Mostly it's the average. So imagine we have put this here and we calculate this, we add them. So 1, 0 is 1, 0, 0 is 0, 0 and 1 is 1. Like that, we do all that stuff, and then in the return we get this. So what is this grid-like structure in an image? So in an image, the grid-like structure is what we call is made out of pixels. So you have now like 20 megapixel or 30 megapixel cameras, all that stuff. So the pixel is basically what makes an image, and 224 by 224 means there are 224 vertical rows of images and there are 224 horizontal rows of images. So it does this process again and again, again and again until every grid is covered, and then we have this output. So what happens is, if your image is very bright, let's say we have a face of a human, and the kernel is designed such it has mathematical expressions such that it has to it has to break the image down into the eyes, the nose, and the mouth of that person. So when you put the convolution on that, on the image, in the output, if you could see the output, you cannot see it because it's in the hidden state. So you just know that something like this is happening. So in the hidden state, what it does is you will get the image where the eyes, nose, and the mouth are somewhat highlighted. And then again convolution takes place, and then it can increase the sharpness, and let's say the goal of our network was to classify whether the person has a mouth or not. Like every person has a mouth, but we have data set where he does not have a mouth. So the image in which he didn't have a mouth, लास्ट में आते आते उस पिक्सल में जो ऐसा बनता है वहां पे माउथ वाले जो होगा वहां पे कुछ नंबर्स होंगे, लेकिन जिसके पास माउथ नहीं था वहां पे कुछ नहीं होगा. So that's how the network can differentiate कि हाँ इसके पास ये नंबर्स है तो उसके पास माउथ है, otherwise उसके पास नहीं. That's what happens in a convolution. हाँ exactly, हर नंबर एक प्रॉपर्टी बताता है. Cool. Principle of convolution done. Okay, recurrent neural networks. So एक चीज जो है नोटिस करने वाली कि convolution में once we have done the convolution of first grid, उसके बाद हमने उस grid को चिल कर दिया, हमको उससे नहीं कर पाएगा क्योंकि फिर next convolution next उस जो लेयर का आउटपुट था उस पे होगा. लेकिन recurrent neural networks में ऐसा नहीं होता. उसमें ऐसा होता है कि imagine this. Okay, so these are the inputs. This is the RNN hidden there, and this is the perceptron that I talked about. And these are the outputs. तो अब जब next layer यहाँ पे होगा, उसमें ये वाला भी जाएगा और ये वाला भी जाएगा. So we understand कि जैसे जैसे लेयर बढ़ती जाएगी तो उसको जब इनपुट आ रहा है वो उसका जो इनपुट आएगी साथ में जो पिछली लेयर थी उसका भी इनपुट आएगा. So what do you think these type of networks are used for? क्या लगता है कि कहाँ पे आपको जरूरत पड़ती है कॉन्टेक्स्ट निकालने की? मतलब क्या हो सकता है डेटा सेट जहाँ पे एक चीज दूसरी पिछली चीज से कनेक्टेड हो? Exactly, sentences, language, translation, all that. क्योंकि इसमें context चाहिए होता है. क्योंकि अगर if I say I football नहीं समझ आएगा. लेकिन अगर उसमें लिखा है I play football तो sentence का meaning है. Same thing in recurrent neural networks. Okay. So These deep learning algorithms are commonly used for ordinal or temporal problems. Temporal means time, which has a time component. So temporal problems such as language translation, natural language processing, speech recognition, and image caption. Okay. So, okay. So I'll tell you the math now. Okay. No math. Okay, I'll tell you first. So in these layers, we have a tan h activation. Tan h function I just showed you, e power minus z plus e power z. So we have that, and then uh, another activation which is, I think it's a ReLU. So we have a ReLU activation and tan h activation. So why tan h? Tan h because you guys know the graph of tan h function, right? It's, I think it's like this and it goes like this. Or not? I think it's some tan it goes like ये वही बस है tan h का कुछ होता होगा ऐसे ही कुछ होता है ऐसा तो kind क्यों क्योंकि लैंग्वेज है आपको कॉन्टेक्स्ट निकालना है कॉन्टेक्स्ट आप कहीं से भी निकाल सकते हो राइट कहाँ से किसका कॉन्टेक्स्ट आएगा नहीं पता लगेगा उसके लिए we need a function which can give value in the whole range कहीं पे भी जा सकती होगा इसलिए tan is function basically so ये हो गया okay then now comes the part which is for the people who have somewhat knowledge of machine learning और जिनको नहीं भी है अब उनको अभी तक यहाँ का समझ आ रहा है डीप लर्निंग पार्ट ही समझ आ रहा है तो जो नेक्स्ट दो तीन स्लाइड्स हैं वो भी समझ आना चाहिए दो ही है तीन नहीं दो है ट्रांसफॉर्मर्स कुछ भी आइडिया है हाँ हाँ जीपीटी सही बात है जीपीटी बार्ड और बिंग का भी है कुछ ऑल्सो चैटबॉट्स मतलब जो बहुत ज्यादा हाई स्केल पे यूज होते हैं वो so ये जो इमेज है दिस इज फ्रॉम द पेपर अटेंशन इज ऑल यू नीड अगर किसी को बहुत ज्यादा इंटरेस्ट है ट्रांसफॉर्मर्स पढ़ने में वो अटेंशन इज ऑल यू नीड सर्च करना उसको पहला पेपर में देखिएगा और कोडर सिर्फ अटेंशन क्या होता है मैं आपको बताऊंगा और फिर एक टी कोडर अटेंशन तो इसका ये इतना सक्सेसफुल क्यों है हमारे पास एलएसटीएम है जीआरयू है और बाई डायरेक्शनल एलएसटीएम है और सीएनएन भी काउंट कर सकते हैं ऐसा क्या है इसके अंदर कि इसकी वजह से इतने लार्ज स्केल मॉडल्स में चैट जीपीटी बार्ड ये सब ट्रेन करने में ये सब पब्लिकली अवेलेबल हो पाए तो बेसिक जो है जो एक कहते हैं ना सार है इस पूरे मॉडल का वो है अटेंशन मैकेनिज्म किसी को पता है नहीं पता होगा तो पता होगा तो थोड़ा सा नाम नहीं पता मैं समझूंगा सो अटेंशन मैकेनिज्म से किसी को कोई हिंट लग रहा है क्या हो सकता है इसमें बात तो सही है और कोई 50% करेक्ट है वो और किसी को कुछ नहीं पता ठीक है तो कौन सा हम बोर्ड पे समझाऊं या फिर मैं ऐसे विजुअलाइज करूं ठीक है तो जो लोग यहाँ सुन रहे हैं जीडीएससी में उनको थोड़ा इनकन्वीनियंस है बात को ठीक है तो लेट्स से आई हैव अ सेंटेंस a cat ate a mouse okay so pardon my handwriting I have not written it okay. Cat ate a mouse दिखा सबको ठीक है तो what we do is किसको पता है कोवेरियंस क्या होता है कोवेरियंस फाइनेंस का एक टर्म है और थोड़ा बहुत स्टैटिस्टिक्स में होता है इसको पता है कोवेरियंस क्या होता है वेरियंस पता है वेरियंस सबको पता होगा तो वेरियंस पता है ना तो ट्राई एंड विजुअलाइज क्या हो सकता है कोवेरियंस
तो डेटा के बीच में
दो डेटा के बीच का डिफरेंस था, बट इमेजिन हमारे पास 512 डेटा इनपुट डेटा है, उनके बीच में उनके बीच का वेरिएंस है, ठीक है। तो कोवेरिएंस इज, जैसे मैंने बोला 512, सो 512 इनपुट डेटा पॉइंट्स सब आपस में कैसे वेरी कर रहे हैं, उसकी पूरी मैट्रिक्स होती है। तो उसमें जैसे 512 यहाँ पे होगा 500, तो नंबर ऑफ डिमेंशंस, नंबर ऑफ रोज एंड कॉलम्स आर इक्वल, राइट? सो लेट्स से यहाँ पे है एक मैट्रिक्स, अब मैं यहाँ पे इसमें वर्ड्स हैं 1 2 3 4 5, ठीक है। मैं यहाँ पे लिखूंगा क्या, ए माउस, ठीक है। ऐसा, तो the thing you need to, that's very clear but also not very clear is that हर वर्ड का खुद के साथ, अच्छा इससे पहले फॉर्मूला भी जाता है, अटेंशन का फॉर्मूला, मैं थोड़ा ज्यादा टाइम ले रहा हूँ उसमें क्योंकि बहुत अच्छी चीज है, तो मैं समझ रहा हूँ कि मजा आएगा, ठीक है। सो वी हैव, दिस इज सेल्फ अटेंशन, मास मल्टी हेड अटेंशन और मल्टी हेड अटेंशन मैं नहीं समझाऊंगा क्योंकि बहुत टाइम चला जाएगा, क्या मतलब, तो we have input, ठीक है। इनपुट है ये सेंटेंस और हमने इसको 3 पार्ट्स में डिवाइड कर दिया, Q, K और V। तो Q है क्वेरी, K है की और V है वैल्यू, ठीक है। तो इमेजिन तुम गूगल पे सर्च कर रहे हो कुछ, तो जो तुमने प्रॉम्प्ट डाला है दैट इज योर क्वेरी, की जो है दिस इज व्हाट इज स्टोर्ड इन द गूगल डेटाबेस, मतलब जहां पे तुम सर्च कर रहे हो वो है की, एंड वी इज द वैल्यू दैट गूगल विल गिव, मतलब सर्च रिजल्ट्स जो है पूरे, दैट इज द वैल्यू। सो अगेन Q is what you have given, K is what is stored in the data of Google, and V is the value that will be given to you after you have मतलब तुमने जब सर्च क्लिक कर दी, ठीक है। तो सेल्फ अटेंशन में क्या होता है कि ये तीनों चीजें सेम होती है, जो क्या डेटा माउस जो सेंटेंस है वही क्वेरी है, वही की है, वही वैल्यू है। अब होगा क्या, तो ऐसा होता है कि जब भी इनपुट देते हैं उसमें एम्बेडिंग्स होती है, एम्बेडिंग मतलब आप एक n डायमेंशनल स्पेस में उस वर्ड को एम्बेड कर देते हो उस नंबर से, ठीक है। तो इमेजिन दिस टू बी अ वेक्टर, दिस टू बी अ वेक्टर एंड दिस टू बी अ वेक्टर। तो जो दो वेक्टर्स के बीच में अगर आपको सिमिलरिटी निकालनी है, सो व्हाट यू विल डू, डॉट प्रोडक्ट, राइट। सो दो वेक्टर्स हैं, इनके बीच में अपने को सिमिलरिटी निकालनी है, तो हम लिख दिया q डॉट k, लेट्स से वेक्टर के लिए r1 q डॉट k, ठीक है। हमने इसको डिवाइड किया अंडर रूट ऑफ d, d मतलब व्हाट इज d, d जो मैंने बोला n डायमेंशनल स्पेस वो n है बेसिकली, तो उसको मैंने d लिखा है, ये पूरा यहाँ पे मैंने लगाया सॉफ्ट मैक्स। सॉफ्ट मैक्स क्यों लगाया, सॉफ्ट मैक्स का जो आउटपुट होता है वो होता है 0 से 1 के बीच में, ठीक है, इसलिए मैंने यहाँ पे सॉफ्ट मैक्स लगाया, और फिर इसको मैं मल्टीप्लाई कर दूंगा v वेक्टर से, क्योंकि ये तो हो गया अपना स्केलर, सॉफ्ट मैक्स में दिया तो भी स्केलर, फिर स्केलर को तो वेक्टर से मल्टीप्लाई कर सकते हैं, सही बात है ना, कर दिया। अब ये जो q डॉट k होगा क्या, ऐसे देखो हर वर्ड का खुद के साथ जो एक रिलेशन होगा वो 1 होगा, सही बात है, हर वर्ड खुद से तो रिलेटेड होती है, तो ये जो पूरा टर्मिनल है यहाँ पे 1 आएगा 1 आएगा 1 आएगा, यहाँ पे भी और यहाँ पे ये वो रीजन। अब लेट्स से और क्या रिलेटेड है 0.8 समथिंग, दिस इज 0.5, ऐसे करके मेरे पास सारी वैल्यू समझ पा रहे हो, सब वैल्यू आ गई। तो एक है ये मेरे पास क्या कहते हैं कुछ डिमेंशंस का, सेम है मेरे पास के कुछ डिमेंशंस का, इसका मैं डॉट प्रोडक्ट ले लूंगा, मेरे पास के लगा जाएगा, तो उस डॉट प्रोडक्ट ये शो करेगा कि इतने ज्यादा सिमिलर है ये एक सेंटेंस का वर्ड, माउस वर्ड ए के साथ कितना रिलेट कर पा रहा है, ये वाला ए कैट के साथ कितना रिलेट कर पा रहा है, ये होता है सेल्फ अटेंशन। सर है हाँ ऐसे का स्क्वायर होता है, लेकिन जब एक मल्टी हेड अटेंशन होता है वो बहुत कॉम्प्लिकेटेड हो जाएगा, वो मैं समझूंगा, और मास मल्टी हेड होता है उसमें ऐसा होता है कि मास वाले आप कुछ जो वैल्यूज हैं उनको मास्क कर दोगे, तो इसके अंदर है कि आप उसको मास्क कर दोगे, तो मास्क इन द सेंस वो नेटवर्क को पता नहीं चलेगा वो क्या है, तो ऐसे इन्होंने किया है, तो अटेंशन मैकेनिज्म सबको समझ में आ गया। वैसे ही एक मल्टी हेड अटेंशन होता है, मल्टी हेड अटेंशन तुम लोग को इंटरेस्ट है तुम लोग पढ़ लेना, अभी पढ़ोगे तो समझ आ जाएगा, ठीक है। ये है नॉर्मलाइजेशन है और एडिशन है, फीड फॉरवर्ड लॉ आगे भेजने का ज्यादा कुछ नहीं, फिर मास मल्टी हेड अटेंशन जो मैंने बोला ऐसे जा जाके यहाँ से ये पूरा इनपुट्स के लिए था या आउटपुट्स के लिए, समझ पा रहे हो, इस पूरे का जस्ट सिर्फ अटेंशन मैकेनिज्म है, इस केस पेपर का नाम था अटेंशन रिजॉल्विंग। तो ये थे ट्रांसफॉर्मर्स यूज्ड फॉर लैंग्वेज ट्रांसलेशन, लैंग्वेज को प्रोड्यूस करना और मशीन ट्रांसलेशन, ठीक है। अब चलते हैं उस पे जिसने नकली इंसानों की फोटो ली, गैस। So GANs, generative adversarial networks, or GANs for short, are an approach to generative modeling using deep learning methods such as convolutional neural networks. So ये है पूरा स्ट्रक्चर GANs का, ठीक है। GANs में क्या होता है, यूनिट स्पेस रियल सैंपल्स, ठीक है। सबसे पहले क्या होगा, जो रियल सैंपल्स है वो जनरेटर में जाएगी, जनरेटर क्या है, न्यूरल नेटवर्क है, बहुत डेप्थ होती है उसकी, और बेसिकली वो न्यूरल नेटवर्क है और ज्यादा कुछ नहीं है, और इनपुट्स जाते जाते उसमें एक नॉइज चलाएगा, नॉइज क्या होता है, नॉइज कुछ भी रैंडम वेक्टर, मान लो 0 0 0 देगा, ठीक है, ये दोनों यहाँ पे ऐड हो जाएंगे और फिर वो जनरेटर पे जाएंगे। जनरेटर क्या करेगा कि उस पूरे डेटा को एक लेटेंट स्पेस का मतलब होता है कि ऐसी जैसे मैंने एनकेमिस्ट्री स्पेस बताया ना, वैसा लेटेंट स्पेस उसमें वो एम्बेड करेगा, वहां पे वो पूरा था फोटो था हमारा 2D फोटो इंट्रोड्यूस है, पता नहीं कितने करोड़ों पैरामीटर्स थे, वो सब कुछ हजार 100,000 पैरामीटर्स के अंदर वो एम्बेड हो चुके, तो अब वो और रियल सैंपल्स दोनों जाएंगे डिस्क्रिमिनेटर के पास। डिस्क्रिमिनेटर क्या होता है, डिस्क्रिमिनेटर तो नाम समझ में आ रहा है, डिस्क्रिमिनेट क्या होता है, असली और नकली जीरो। तो अब इसको कैसे पता चलेगा, हमने उनको लेबल दिया हुआ है, जो यहां से आ रहे हैं उनको लेबल देते हैं 0 0 मतलब फेक, और जो रियल सैंपल है वो जो आ रहे हैं उनको लेबल दिया हुआ है 1 मतलब रियल। तो ये दोनों आए, डिस्क्रिमिनेटर शुरुआत में जनरेटर को भी कुछ नहीं आता, डिस्क्रिमिनेटर को भी कुछ नहीं आता, तो इट्स लाइक दो अनपढ़ लोग आपस में ज्ञान की बातें कर रहे हैं, किसी को कुछ नहीं आता तो फर्क नहीं पड़ेगा। लेकिन फिर धीरे धीरे जैसे डिस्क्रिमिनेटर है उसने कुछ डिस्क्रिमिनेट किया, तो बताया मान लो 50% नकली चीजों को उसने असली बोल दिया, असली चीजों को नकली बोल दिया, ठीक है। तो यहाँ पे लॉस फंक्शन हम डिफाइन करते हैं व्हिच इज मोस्टली बाइनरी क्रॉस एन्ट्रोपी, उसका फार्मूला आपको दूंगा, सर्च कर लेना है। तो यहाँ से यहाँ पे मान लो लॉस फंक्शन से कोई आउटपुट आया, कोई लॉस में गया, अब लॉस से क्या होता है, यहाँ के जो लॉस के बाद ग्रेडियंट डिसेंट पढ़ाया था ना कि उसमें, वही ग्रेडियंट डिसेंट से जो ऑप्टिमाइजेशन होता है पैरामीटर्स का, वो जनरेटर के पास जाता है और उसको पता लगता है कि इसने 50% बोला है, मेरे को तो 100% लगा, क्योंकि ये चाहता है कि डिस्क्रिमिनेटर मेरी सारी इमेजेस को रियल बोले, लेकिन डिस्क्रिमिनेटर का नाम डिस्क्रिमिनेटर है, वो चाहता है कि मैं सारी फेक को फेक बोलूं, रियल को रियल बोलूं। तो जैसे इसका लॉस यहाँ पे जाएगा, सो It will know what I have to do in order to get better. Again, what happened was he got the real sample and the fake sample as well. So he knows a little bit what does a real sample look like and what does a fake sample look like. So he is also a bit mature now and he is also a bit mature. So accordingly इसका output आएगा और accordingly ये discriminate करेगा. ऐसे करके ये लोग अच्छे better होते जाएंगे, सीखते जाएंगे. And then there will come a time जब जनरेटर मतलब टाइम आएगा लेकिन हम चाहते हैं ऐसा टाइम है कि जनरेटर ऐसी इमेजेस बना दे कि ये डिस्क्रिमिनेटिंग करता है. जब ऐसी बना देगा तो हमको ऐसी इमेजेस मिलेंगी जो मैंने तुमको उसमें दिखाई रियल बंदों की जो तुम सॉरी फेक बंदों की जो रियल लग रहे हैं. ठीक है, तो ये करने से टारगेट इसकी मैथ्स काफी हैवी है तो समझाने में बहुत टेक्निकल है नहीं समझेंगे. हाँ एग्जैक्टली. सो दैट इज द ब्यूटी. हम लोग को क्या करना है कि ये भी अच्छा रहे और ये भी अच्छा रहे लेकिन ऐसा हो कि इस देखो जो लॉस जो मैंने बताया अभी ये चाहता है कि लॉस जो है वो मैक्सिमाइज हो क्योंकि मैं सारे फेक को फेक बताऊं सारे रियल को रियल बताऊं तो इसके लिए लॉस चाहिए इसको मैक्सिमाइज. लेकिन ये जब तक लॉस मिनिमम हो क्योंकि अगर लॉस मिनिमम होगा तभी तो बता पाएगा कि हाँ ये फेक का रियल था वो डिस्क्रिमिनेटिव कंफ्यूज हो रहा है तो मेरे इनपुट मेरे जो जनरेटेड है वो काफी अच्छा है तो मैं बहुत सही काम कर रहा हूँ. तो ये मिन मैक्स गेम चल रहा है इन दोनों के बीच में. ठीक है, इसमें एक कांसेप्ट होता है गेम थ्योरी का मैथ्स इक्विलिब्रियम जो तुम आपने पढ़ा होगा. वो एक पॉइंट आता है जब मिन मैक्स गेम की आइडियल वैल्यू पहुंच सकती है. मेरे को भी नहीं पता कि क्या मैथ है उसके बाद प्रोग्राम से आती है गेम थ्योरी आती है सर. तो यहाँ से जब मिन मैक्स गेम की आइडियल वैल्यू पे पहुंच जाएगा तब हम बोलेंगे कि हाँ बेस्ट नेटवर्क है. तो बेस्ट नेटवर्क है बेस्ट आउटपुट है इससे बढ़िया नहीं मिलेगा. ठीक है, तो ये बहुत बेसिक क्या है और इसका लॉस सबसे बेसिक बाइनरी क्रॉसिंग होती है. अब इसमें दिक्कत क्या है? एक दिक्कत होती है कि मान लो तुम लोग 5 काम कर सकते हो. ठीक है, और तुम्हारा एक सुपरवाइजर है जो तुमको बताएगा कि तुमने अच्छा किया है तुमने गलत किया है. लेकिन सुपरवाइजर तुमको ये नहीं बोलता कि तुम ये भी करो 5 काम करो ये नहीं बोलता. बस वो ये बताता है कि दिस इज द वर्क दैट यू हैव डन वेरी गुड एंड दिस इज द वर्क दैट यू नीड टू वर्क ऑन. सो जनरली क्या लगेगा इंसान इफ यू आर गुड एट समथिंग एंड यू आर गिवन टास्क or you are given the work to do 5 things. So what you do is the thing you are better at will do that most frequently. ठीक है, सही बात है. तो अगर तुम एक ही चीज बार-बार करोगे तो जनरेटर के टर्म्स में वो क्या होगा कि तुम एक ही आउटपुट बार-बार जनरेट कर रहे हो जो तुम बहुत अच्छे से कर सकते हो. लेट्स से एंडलेस डेटा सेट है 0 से 9 का. उसमें जब मैं यहाँ पे गया तो 8 जो नंबर है 8 ही बहुत अच्छे से बना पा रहा है. इसके बेटर नहीं बता पा रहा कि इसने बनाया है उसको लग रहा है रियल है लेकिन बाकी सारे वो बना रहा है. बाकी सारे उसको पता है कि ये फेक बना रहा है बस 8 में उसको कंफ्यूजन है. तो उसको बस 8 में कंफ्यूजन है बाकी सब में उसको लग रहा है कि हाँ ठीक है तो जाएगा. अब जनरेटर क्या है जब उसको लॉस पूरा आएगा यहाँ से तो उसको पता चल जाएगा कि इसको 8 नहीं समझ में आ रहा है तो मैं 8 बनाता हूँ. 8 बनाता जाएगा. तो अब ऐसे तो चाहिए नहीं हमको ऐसे थोड़ी चाहिए कि बस 8 ही बनाना है. हम तो चाहते हैं 0 से 9 सारे वो बनाए. तो ये प्रॉब्लम को बोलते हैं मोड कोलैप्स. मोड कोलैप्स क्यों? क्योंकि 0 से 9 तक के सारे जो डेटा थे इनपुट्स थे उन सब का डिस्ट्रीब्यूशन होगा. ठीक है, अब वो सिर्फ एक आउटपुट जनरेट कर रहे हैं. 8 जो मैंने एग्जांपल दिया सिर्फ 1 जनरेट कर रहे हैं. तो 8 जो है उस पूरे जो डिस्ट्रीब्यूशन है उसमें 8 का ही मोड होगा जहाँ पे 8 बहुत बार आ रहे हैं बहुत बार आ रहे हैं. तो उस वजह से वो सिर्फ ये बनाने लगे तो उस मोड पे आके उस डेटा के मोड पे आके कोलैप्स हो चुका है. तो इसलिए उस प्रॉब्लम का नाम है मोड कोलैप्स और उसको टैकल करते हैं. गैंस का एक अपग्रेडेड पार्ट है अपग्रेडेड टाइप है W गैंस. W इज फॉर वॉसिस्टीन लॉस. वो नहीं बताऊंगा. वॉसिस्टीन गैंस में लॉस फंक्शन चेंज हो जाता है थोड़ा सा और उसके बाद फिर आते हैं कंडीशनल गैंस. कंडीशनल कैम्स में और लॉस को चेंज कर देते हैं। फिर उसके बाद आते हैं प्रोग्राम्स का आइडिया नहीं था ऑनेस्टली। उसके बाद आता है स्टाइल गैन जो है जिसने वो साइट जो इमेजेस जनरेट की थी, फेसेस जनरेट किए थे, दैट इज पॉसिबल बिकॉज ऑफ स्टाइल गैन। तो दिस इज ऑल दैट वी हैव अबाउट डीप लर्निंग आई गेस। नहीं कुछ यस रिसोर्सेस इसको भी कैसा लगा पहले ये डीप लर्निंग समझना ही ये समझ में आया, मैं इसके लिए मेहनत करके आया था बहुत इम्पोर्टेंट आया ना। ठीक है तो I think that's it for the workshop. Yes, and these are the resources. I highly recommend you to go through this and the machine learning specialization. First go through this, and then when you understand everything, then move towards transformers and GANs. And PyTorch tutorials by Daniel. मैंने personally इसका course किया था यूनिवर्सिटी से, and मैं at least 10-15 लोगों को recommend किया है इसी के पास 60 अच्छा ठीक है इसका promotion किया 10 सब tutorials by Daniel personally सबको पता है कौन है Daniel personally machine learning के वैसे और समर आदर इंस्टीट्यूट की आईडी को बाकी एनालिटिक्स का कोर्स है बेसिक मशीन लर्निंग पैंडास स्टैटिस्टिक्स और हाँ ये सब पता चल जाएगा। तो अनसुपरवाइज्ड और लॉजिस्टिक रिग्रेशन और लीनियर रिग्रेशन समर एनालिटिक्स आईटी ऑडियो ये सब हो जाएगा। एडवांस मशीन लर्निंग स्पेशलाइजेशन एंड डीप लर्निंग स्पेशलाइजेशन इससे पूरी मैथ्स को समझ में आ जाएगी। गिवन दैट कि तुम बस वीडियो नहीं देख रहे हो तुम पूरा समझ जाएगा अच्छे से पहुंच कर PyTorch tutorials by Daniel Koch and TensorFlow tutorials by Rahul Person। PyTorch TensorFlow frameworks है इसमें हम लोग सारे मॉडल्स को बनाते हैं सब कोड करते हैं। तो yeah that's it, thank you so much।
यहाँ पर से कोई भी ऐसा उसका जीडीएससी पर रजिस्ट्रेशन नहीं हुआ सभी को कर दिया जीडीएससी पर और किसी का और वो तो सनी में बता दो कि उसका रजिस्टर करना जरूरी है और टास्क का जो एलिजिबिलिटी नहीं रहेगा सर्टिफिकेशन के लिए बताओ जिसका रजिस्टर नहीं हुआ जिनका रजिस्टर नहीं हुआ वो मुझे डीएम कर देना क्लियर या आज हम लोग उसको एक वीडियो शेयर कर देंगे कि उसका रजिस्टर कैसे करते हैं बहुत सिंपल सा प्रोसेस है और पहले का जितना कम्युनिकेशन आ रहा है ठीक है तो वो देखिए अगला इसका 30 को होगा सेशन उसमें पार्ट बेसिक सा इंट्रोडक्शन था थोड़ा ओवरऑल करेंगे या ओवरऑल इंट्रोडक्शन में यूज ऐसे चीजें पर डिस्कस हो रही है कि और तुम्हारा लेवल यूज ना लोगों को फिलहाल जो अपना ज्यादा उस बारे में जानते ना हो लेकिन अगला जो वर्कशॉप होगा वो थोड़ा सा एस्ट्रोनॉमी ओरिएंटेड होगा उसमें उन लाइब्रेरीज के बारे में बात करेंगे जो कि एस्ट्रोनॉमी में यूज होते हैं उन पाइप लाइब्रेरीज के बारे में ठीक है जैसे एस्ट्रोपाई हो गया एस्ट्रोनॉमी हो गया या और भी डाटा एनालिसिस का लाइब्रेरी